In this video, we'll be looking at rational and irrational numbers. We'll be operating with them and classifying the result. So part one asks us to define terms using our own prior knowledge or a math glossary. So let's look at some of these terms. A rational number. A rational number, you'll remember, is a number that can be expressed as a fraction or as a terminating or repeating decimal. We know that the set of rational numbers contains other numbers, such as integers, whole numbers, and natural numbers. Irrational numbers. A number that cannot be expressed as a fraction, or a number that is a non-terminating, non-repeating decimal. So we can add to that. The square root of a non-perfect square is always an irrational number. That is a non-perfect square that's a whole number. That will be an irrational number. Now these words go back to early grades, and we know that the word sum means the result of an addition problem. Difference has to do with a subtraction problem. Product, the result of a multiplication problem, and quotient is the result of a division problem. So hopefully those words are familiar. Now what we'll do is we'll look at part two, which helps us to classify numbers. And then in part three, we're going to classify expressions. So part two, the number 0 is a rational number, right? Because it can be expressed as a fraction. 0 over 5, for instance, 0 over 3, that's a rational number. The square root of 5, on the other hand, that's irrational because 5 is not a perfect square. And 10 is a rational number because it's an integer, it's a natural number, it's a whole number. It's a number that can be expressed as a fraction or a terminating decimal like 10.0. All right, can you handle these three numbers on the right? Classify those numbers as rational or irrational. Put the video on pause. If you want to grab a calculator, that could be helpful. And then come on back. So the square root of 16. Now 16 is a perfect square. Therefore, the square root of 16 is a whole number, 4. And as a result, square root of 16 is a rational number. 16 is also a rational number. But the square root of 20, because 20 is not a perfect square, if you entered that into a calculator, you'd find that these digits go on forever and there is no pattern and it never terminates. So the square root of 20 is an irrational number. All right, let's look down at part 3 now. To classify each expression as rational or irrational. All right, now it says you can use a calculator, but what we're asking you to do in the first example here is we're asking you to consider the square root of 16, which we set up above was rational, plus 16, which is also a rational number. That will give us another rational number, right? Because it's 4 plus 16, which is 20. All right, down here we have a rational number, which is 10, plus an irrational number. And if I were to add those together, I would still, I hope you agree, have a decimal part that goes on forever with no pattern and never terminates. So therefore, this one is an irrational number. So I'm beginning to think that it's possible that a rational plus an irrational number might always be irrational. Not sure. Thinking about that, right? All right, so trying to also, while we're doing this, trying to generalize. All right, this is an irrational number plus a rational number. Well, it's probably irrational, like up here, because I'm going to end up with a decimal that goes on forever, that never terminates and never repeats. Irrational. Okay, the square root of 20. It's got this decimal part that goes on forever with no pattern. The square root of 5, same thing. So when I add these two together, I'm going to have a decimal that goes on forever with no pattern. That's irrational. All right, so your turn to do these 4 examples over here. You can picture what the result would be and classify it using your prediction. You can also use a calculator to check your prediction. Take a few minutes, put the video on pause, and come on back. Okay, let's see how you did with these. We'll show you the answers all at once. The first product will be irrational because while multiplying a decimal by 10 moves the decimal 1 point to the right, you're still going to have infinitely many decimal digits with no pattern that never repeat. Now, this is an interesting example. While both factors are irrational, when you multiply those numbers together, you get 100, the square root of 100 being 10. So pay attention that we cannot generalize that any irrational number times any irrational number will always be irrational. That's not true, okay? All right, now down here, 10 times basically 4 is 40. That makes sense that it's rational. Turns out the square root of some number by the square root of the same number will be the number. So the square root of 20 times the square root of 20 will be 20, which will be a rational number. All right, now that we've done some specific examples, let's go on to the next part, which is generalizing. And what we're going to do is we're going to ask you to replace each question mark with the word rational or irrational. So we'll get us started, okay? The sum of a rational number plus a rational number, well, any two fractions, when you add them together, will always be a fraction. So that's going to be rational. Any two terminating decimals or repeating decimals, when you add them together, will still be terminating or repeating. Okay, this one, the sum of a rational plus an irrational number, well, I'm still going to end up with decimals that go on forever with no pattern. So this sum is going to be irrational. Now, this one we kind of we tip you off to be careful because we're telling you there's an exception. So any two irrational numbers, when you add them together, right, you would think would always be irrational. That's what you would think. You would think you're always going to have decimal parts of the sum that go on forever with no pattern. But there is an exception to this rule, which we want to really be careful that we consider these exceptions, okay? And the exception is pi is an irrational number. Negative pi is an irrational number. But gee, when we add these together, we get 0. Same thing with like the negative square root of 21 plus square root of 21. That's 0. So we really have to say almost always be. It will almost always be irrational, but there are a couple of exceptions. So be careful with that. All right, the product now of a rational number times a rational number. Now listen, if you multiply any fraction by any fraction, you're still going to get a fraction, right? You're still going to get a rational number. If you multiply any repeating decimal by any repeating or terminating decimal, you'll still get either a terminating or repeating decimal. Right, this one here has an exception. So we want to pay attention to this word almost always. Okay, the product of a rational number times an irrational number. All right, let's think. Rational number, it's a fraction, or it's a decimal that terminates or repeats. If we multiply that decimal that terminates or repeats by a decimal that never terminates and never repeats, you would think that we're going to get an irrational number? That's what you would think, right? I would think so. You would picture the end part of that decimal to go on forever with no pattern. Apparently, there's exceptions. So what kind of exceptions might there be? And you always want to think about the number 0. 0 plays a significant role here because if I multiply 0, which is a rational number, by any irrational number, we're actually going to get 0 as a result. So let's check that out. Yeah, my exceptions have to do with the number 0. So almost always the product of rational times irrational will be irrational, but you be careful with that exception. All right, let's go on to the last one. The product of an irrational number, remember, it's a decimal that goes on forever with no pattern, never terminates, times another number like that. You would think, right, would be irrational, wouldn't you? I would think that. I would think that if I multiply those two decimals together, I'm still going to get a decimal that goes on forever, and there's no pattern. It never repeats. However, we have exceptions to this rule as well. So almost always be. All right, so my exception, we've actually come across in the earlier part. Let's look. All right, my exception, the square root of a number times the square root of that number will be the radicand itself. So the square root of 70 times square root of 70 is 70. Now look, these are irrational numbers, but the product is rational. Do you see? All right, another type of example. These numbers are both irrational because they're not 2 and 8 are not perfect squares. But when I multiply them together, I get a perfect square, which I can take the square root of. So be careful here. There are quite a few exceptions. If I take the number 45, which is irrational, the square root of 45 is irrational, times the square root of 20, I'm getting the square root of 900, which is rational. So in this video, we reminded ourselves what are we talking about regarding irrational and rational numbers. We classified numbers. We looked at operating with those numbers and classifying the results. And we tried to come up with some generalizations.